Hi, pre-calculus. This lesson is going to review a lot of the things we've done, but it is also going to show us more in depth the graphs of these functions that we've been working with, logarithms and exponentials, which are the inverse of each other. So what we're going to do today, you'll need your graphing calculator for, so go ahead and get that out. Make sure it is charged, or you can charge it while you watch this, and fill these notes out as you go. All right, so we'll be kind of long, but I'm gonna try to go quickly, so if there's anything you need help with, you can rewatch it or ask me. So an exponential function is, and this should be familiar, but an exponential function is a function where the unknown is in the exponent, and that's why it's called exponential, because our unknown is in the exponent. And it's written like f of x, or just remember that's the same thing as y, equals b to the x power. And b is your base. B is the thing that's being raised to the power. But what we know about it is that it's bigger than 0, so it's not a negative number, and it also cannot equal 1. And then our x's, anything that we have in the exponent, is a real number. And so those are any number you really will think of, except the square root of negative numbers. Those are not real numbers. Why, then, can b not be 1? If b was 1, if it was 1 to the 4th power, that would be 1. And if it was 1 to the 2nd power, it would still be 1. And so you would have this line of y equals 1. Y equals 1, which is just this horizontal line. And that is not an exponential function. And so that's why b cannot be 1. And here we have a list of the things that we know about exponential functions. So it could be daunting, but I'm going to break it down for you. It says that the domain of an exponential function consists of all real numbers. So the domain, what x is allowed to be, are these real numbers. And then the range, so the domain is real numbers, the range is all positive real numbers. So that means the output, or what it equals, like this number and this number, is all going to be positive, any positive real number. And that's our base cannot be negative. It has to be bigger than 0. So that's your domain, your range. So what does that mean when we look at our graph? If the x's are allowed to be anything from negative infinity to infinity, right? Those are all the real numbers, and that's your x-axis that goes left to right. Then we're going to see our function go from the furthest this point to the furthest this point. And then our range, how high or how low does it go? If this is your y-axis, it's only the positive numbers. So it's gonna stop at some point. It's gonna stop there and just be above here, but it's not gonna exist anywhere below here because those are negatives. So you've got your y-axis and your x-axis. Your x-axis is your domain. Your y-axis, the values on that are your range values. So you're looking at a graph that's only existing in quadrant 1 and in quadrant 2, or the top half of a coordinate plane. The graph of an exponential function goes through the point 0, 1. That is like your home base point, 0, 1, and then it moves. And it goes through 0, 1 because when x is 0, y is going to be 1. If it's b to the x, y equals b to the x. Well, then if it's y equals b to the 0 power, anything to the 0 power is 1. So y is 1 when x is 0. So it has this base point of 0, 1. And if you look at these two down here, these are examples, and you see that we've got 0, 1 on both of them. And you also see the thing we just talked about in part 1 right here, that it is existing, these functions, these are exponentials, are existing only in the top 2 quadrants. So where does the parent function exist? So it exists in the top two quadrants, or quadrant 1 and quadrant 2. If b, your base, because this will change, is bigger than 1, then it's going to be, this is an increasing function. And it's going up. So if you were to, if this was like how much money, this is a function of time perhaps, and this is how much money you make, your money is increasing. You're seeing it go up, right? So that's good. That's an increase. If this was time, again, on your x, and your y was money, again, this would be a bad thing. As time increases or goes from smaller to larger, my money is going down. So you would want to either get a new job or change that investment or whatever it was. So this is an increasing function, and this is a decreasing function. Now, what makes it decreasing is if your base is something in between 0 and 1. Well, what numbers are between 0 and 1? Those are your fractions, right? Like, and obviously you can have fractions outside of 0 and 1, but these are numbers that are less than 1, but bigger than 0. Because remember, b can't be 1, and it has to be bigger than 0. So it's like 1/2 or 2/3 or something like that. So if your base is a fraction, and I just mean that in a very basic way, between 0 and 1, it's going to be decreasing. And if your base is positive, a positive whole number, then it is going to be, or I could just say whole number, then it's going to be increasing. Okay, 1-to-1, we don't really need to get to that. And this graph also has a horizontal asymptote at the x-axis, which is where y equals 0. So it never can actually equal that. It can never approaches it, but it doesn't actually equal it. And so if you remember those asymptotes, those like invisible force fields that the function just cannot cross, that's what that is. It gets close to it, but it doesn't actually go through it. All right, so this first function we're going to graph, or do it by hand, and then we'll do the other ones on our calculator. It says sketch the graph of this. So I'm going to make a table where I have my x's and my y's, and y equals this function. So if I have, let's say, we know 0 is supposed to be 2 to the 0 power, and that's 1. So we know the point 0, 1 is on our graph. So 0, 1, we knew that because that's what it said above. And then let's see if we have, and here, what's our base? So what's our base? Our base is 2. So what that means is that it's a whole number, so it's going to be an increasing function. So that means it's going to be going up from left to right. Let's say, what if it was 1? This would be 2 to the first power, so that would be 2. So the point 1, 2. So 1, 2. What if it was 2? That would be 2 to the second, so that'd be 4. So the point 2, 4. 2, 1, 2, 3, 4. If it was 3, it would be 2 to the third, which is 8. And so, wow, look at how fast those numbers are getting bigger. 4, 5, 6, 7, 8. And that's why these are exponential. When people describe something as growing exponentially, it's not growing at a steady rate. It's not growing like 2 every day. It's growing like super fast, and that's what's happening here. It's not increasing like we go from 1 to 2, and then we go from 2 to 4, and then we go from 4 to 8. That's doubling. It's getting bigger faster. It's not just increasing by the same number. But what about like -1? What's 2 to the -1? Well, remember, that's the reciprocal, right? Anything with a negative exponent is the reciprocal. So the reciprocal of 2 to the first is 1 over 2 to the first. So that would be 1 over 2. So -1 has a value of 1/2. And then -2 has a value of 1 over 2 to the second, which is 1/4. So we're getting smaller, and then you have an eighth, and then it's just going to keep getting smaller and smaller. But again, this is the asymptote, so it's never going to cross the x-axis. It's just going to get as close to it as it can. So that is what your function looks like. But making a table is important to know how to do, so that you can graph any function, no matter what it looks like. All right, these are going to be comparisons to this function that we just did. So it's a transformation. Now this first one you see, oh my goodness, what does it have? It has a fraction. So I'm going to go ahead and put this in my calculator. And let's see, I will turn my camera on for you so you can see this. All right. So here we have you hit the y equals, and our first one was 1/2, right? So put in parenthesis, 1 divided by 2, close the parenthesis, raised to, I'm going to hit this caret, the x, remember the x is right here, next to your alpha, and then I hit graph. Now, because it's a fraction, we expect this to be decreasing, to be going down, whereas the first one we had went up. So now this one's going down. Because it's a fraction. The base is a fraction between 0 and 1. The second one that we are graphing, actually, I don't have my notes, so let me look on here. The second one that we're going to compare it is 2 raised to, okay, and then put parentheses, x minus 3, close the parentheses, I'm going to arrow over so I can get down, and then I'm going to hit graph. Now this one's going to be, see how this color's red? It's going to be in red. So, oh wow, okay. So remember the point 0, 1 is always on our graph. So we see in the blue 0, 1's right there, and then the one we did on our paper would go up here this way, 3, 0, 1 as well. This one, the 0, 1 has gotten shifted over here. I guess it's right here. That's where 1 is, right here. So 1, 2, 3. It got shifted over 3 to the right. Now that actually makes sense, because if you see the transformation, we're subtracting 3 from the x. Remember, when you do a transformation to the x, it goes the opposite direction. So minus 3 you would think goes left, but it goes right 3. So there's your transformation on that one. It moved the graph to the right 3. The next one is 2 to the x power, and then an arrow over so you can get out of that exponent, minus 3. So that's going to take the function that we graphed by hand, and it is going to shift it in which way with the minus 3. It's going to shift it down 3. So when I look at my graph, this one is a black line. It is that first function that we graphed, but it has been shifted down 3 units. Down 3 units. So we started at the point 0, 1 right here, and it goes down 3. 1, 2, 3. So we're hitting it might be a little confusing because it's not at 0, 0, it's at 0, 1. So that point 0, 1 gets moved down 1, 2, 3 points, and now I'm hitting the y-axis at 0, negative 2. And we see it has the same shape, but it has gotten shifted down. Okay, and then our last one here is negative, so I can use this button right here, negative 2 raised to the x power. So what this is changing is not my x values, but my y values, because my x is staying the same sign, but my y's are changing. So my y's are now going to flip. So instead of being positive, now that purple line is going down. So whereas our other graph was above, the one we graphed by hand, this one is going down because my y values have gone from being like 0, 1 to 0, -1, or 1, 2 to 1, -2, and so on. You know, it's gone from being up here to now being the point down there. All right, let's go back to our notes. So those are all the transformations that we saw, that we've done before. These ones just reiterate kind of what we just did. This function right here is the one we just did where the y's change, right? And so on here, where our first graph, I'll just put this 1, 2, 3, 4, 5, 6, 7, 8. This is the one we just did before. I'll dash it like this. If we're graphing the one that we have here, it's actually going to be this one flipped. So it's going to be here, and then here, and then 4, and then 5, 6, 7, 8, -8. So it looks like this. That should be at a half, a fourth, an eighth. Hopefully that's ringing a bell. So that's what that one looks like. Now, what does it look like over here when the x is negative? So instead, what we had in our graph originally was the y's changed. Now our x's are going to change. And if you want to, you can do this in your calculator. I'll do it just to confirm. But think about what should it look like if the x's are changing. If my x's are switching values, then instead of being positive, they're going to be negative. And so instead of it being +1, it's going to be -1. So here we have our x and our y values. When x is 0, y is still 1. But when x was 1, y was 2. So now it's going to be -1, -1, 2. And when it was 2, it was 4. So now when it's -2, it's going to be 4. And when it was 3, it was 8. So now it's going to be -3, 4, 5, 6, 7, 8, 8, like this. So it's flipped. Now it's flipped across the y-axis. And that's what you expect when you make the x negative. So those are just the transformations that we've done before. We've done them. You've done them in Algebra 2, so those should be familiar to you. But also know that you can always use your calculator or use a table if a calculator is not available to you. All right, now this one is another transformation. What are a few things that we notice? It's y equals 1/2 to the x power plus 1. So it's an exponential. And what is my base? My base is 1/2, which means it's going to be a decreasing, right? Decreasing function. And we have this transformation. What is that transformation doing to it? It's going to move that whole function up 1 unit. So our base point of 0, 1, our home base point of 0, 1 is going to be moved up 1 unit. So if we go from 0, 1, now we're going to be at 0, 2 because it's moved up. If we were just doing a rough sketch of that, if it's decreasing, then it's going to look like oops, I didn't mean to erase that. roughly it's going to look like this, right? It's just going to be decreasing down with the shift of it going up 1. All right, so that's that. All right, let's move on. So the natural base E, we've talked about this number E, which is 2.71828, and it goes on forever. It's an irrational number. And it appears in nature, hence why it's called the natural base. And it's a number. So don't think of E as something that's abstract, but it's a number. And we can graph functions with a base of E, and we call those the natural exponential functions. And so you'll see this graph, and this picture right here should look very familiar. Look at our base point, our home base point of 0, 1 is still there, and it's increasing. If x is 1, y is, if we have a function of, here we go. Okay, so when x is 1, y is 2, if you have this function. If you're looking at this one right here, you're using this function, and you see that the E is the one in the middle. That red line is in the middle of those two. So these functions are corresponding to the line that they're next to. So it looks very similar to those. We can evaluate those by just plugging numbers, and this should be familiar. If we have the function f of x equals e to the x, well, what is it when x is 0? So then I just substitute a 0 in, and that would be 1, right? Anything to the 0 power is 1, so 0, 1, which is that home base point that we've used before. It's that point that you can rely on and move if you transform these. Now, if it's 1, then you have e to the first power. Well, that's just e. So when it's 1, f of 1 is e. So 1 comma e, 2.71, blah, blah, blah. Is it 828? And then what if it's negative 2? F of negative 2 would be e to the negative 2. That's f of negative 2 would be 1 over e to the second. So, clear, let's see. To do this on your calculator, I'll show you this in case you're not sure. To do this on here, you would go to, over in this column, you have see that blue e to the x. So to hit the blue button, or hit the blue button so you can get the blue type. And then we have e, and then we can put in to the negative 2 and hit enter. And oh wait, what did I just do? Negative 2, enter. And small number, small decimal, because it's 1 over e to the second. So there we go. Back to this. So this is 0.135. So when x is negative 2, it's 0.135. So as x is negative, that's 0, negative 2, it's super small, which makes sense because it's going like that, right? So let's move on to these. What do the graphs of these look like? Well, we have that point of 0, 1, and it's going to go like this, and we're just doing a rough sketch. Now, what happens, this is e to the x, what happens when it's e to the negative x? We still have the point 0, 1, but what's happening? We're changing my x values to negative, so it's going to be a reflection across the y-axis. So instead, it's going to look like this. So it's reflected across the y-axis, and it is now decreasing. And you can confirm that on your calculator if you would like. All right, now, I was asked when we were in class, how we actually use logarithms in real life. I think this was in my Block 4 class. And compound interest or any interest sort of problems that use an exponential, any problem that has an exponential in its equation, if that's the unknown, then now you have an exponential or a logarithmic equation, depending on if you have to use the inverse, to solve it. And so these are examples of when you would use these, and these are kind of cool problems. So we're almost done. I know this is getting long, but so far it's been pretty much a review. So now compound interest means that like you are putting money into an account and they give you money back for leaving money into in an account. And there's lots of different ways you can do this, but to get money back, if you put $100 in, they're going to give you a little bit money every time. But now, like, let's say they're giving you, this is 5%. 5% is a lot. And if they give you 5% of $100, they'll add that to your total. And then the next time they calculate your interest isn't on $100, it's changed because now you have more money in your account because of the interest that you got last time. So we have to be able to calculate, okay, how much money will you have in an account? If it's compounding, you can say annually, which means once a year, weekly, which is 52 times a year, daily, which is every day, 365 days in a year, or we can say continuously, which uses E. And so that's what these two equations have for us in 1 and 2. You're going to read a word problem and you're going to have to pick that out. How is it compounded? If it's compounded continuously, you always use a pert. A pert. Like Pert Plus used to be a really popular shampoo when I was in high school. So that's how I remember it. But a pert. And then if it's compounded any other way, other than continuously, then you're going to use the first equation, which is a little bit more complicated. Not a cute little way to memorize that. And the things you need to know about these word problems are these formulas. Like A is your initial, is the amount that you're going to have, or your balance. So that's the amount or the balance that you'll have after you've, put money in for a certain number of time. The P is your principal, which is the amount you start with. So if you put $100 into an account, that's your principal. And then if you leave it and you get $5 in interest, now you have $105. That's your A. That's how much you have after a certain amount of time. Your 1 is just the number 1. R is your rate, which is the percent, which you have to change to a decimal. So you always have to change it to a decimal, and that is something that people always forget. You have to change your rate to a decimal. And then we have N, which is the number of times per year that your interest is compounded. So if it's compounded weekly, then there's 52 years in a week, so it's compounded 52 times. So N would be 52. Quarterly is 4 times, so N would be 4. And then your T is time, but it's time in years. So again, it's easy when they give you like 5 years, you'd put 5 in for T, but if they give you 6 months, you would put in 1/2 for that. So T is the time in years that you use this. All right, so here we go. Here's our first example. So suppose that $100,000 is invested at 6.5% interest, compounded semi-annually. Find a function for the amount to which the investment grows after T years, and then find the amount of money in the account at 4 years and at 8 years. All right, so suppose that $100,000 is invested. So this is my P, that's my principal. That's how much I'm starting with. My rate right here is my 6.5%, and it's compounded semi-annually. This is twice a year. Okay, so for part A, it says find a function for the amount grows after t years. So we'll just use the first equation. A equals P times 1 plus R over N to the NT. And we're going to plug in what we know. So I don't know my amount yet, because that's what I'm going to write, a function for the amount after t years. So the amount after t years is going to equal my principal, 100,000, times 1 plus my rate. Now, what do I have to do with my rate? Yep, I have to change my rate to a decimal. So that would be 0.065 over my n, which is the number of times per year it's compounded, so 2, raised to the power of 2, same number, and then t. How many years? I don't know. So t right there. And so here is your function. It's a function. It's in function notation, because instead of just having a equals, you have a to a parentheses t, meaning the amount as a function of time. So then in part B, it says find the amount of money after 4 years and after 8 years. So the amount after 4 years is going to be this equation that we just wrote, and then 1 plus 0.065 over 2 to the 2 times 4, because that is replacing my t, 4 years. So then this is 100,000 times 1 plus 0.065 over 2 to the 8th power. So to put this in your calculator, it is important that you follow your order of operations. I always do this part first. So I do 0.065 divided by 2, and I get that number, and I add it to 1. So now I'm at 100,000 times 1.0325 to the 8th power. Now be careful, because what is being raised to the 8th power? Only the 1.0325, not the 100,000. So you're going to take your number that you have, and then you're going to raise it to the 8th power, and then you have 100,000 times 1.291577, blah, 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 blah. All right, now you don't want to round, okay? That's super important. Don't round your answer, because this is a big deal. When you have things that are exponential, they rise really quickly or they fall really quickly. You don't want to be rounding a number and then raising it to a power. So leave it in your calculator as it is, and then just hit times 100,000, and you'll get your answer. 129,157.75. And since it's money, we want to round to the nearest hundredths place, the second decimal, and make sure it makes sense in terms of money. So this is how much money I will have. If I start with $100,000, how much money will I have in 4 years? The amount in 4 years is this much. That's how much money I'll have in 4 years. Wow, so I've made like $29,000, almost $30,000. Well, not quite, but 29. Okay, so now how much would I have after 8 years? So I'm going to let you calculate this, and we'll check our answer. So after 8 years, you're going to change everything here, and you should have 100,000 times the 1.0325 times to the 16th. So 1.0325 raised to the 16th times, that is 1 66817.25. So that is how much money you'll have after 8 years, which is cool. It's double the time, but it's more than double the money that you are getting in interest. All right. Here is another question where it's saying that you have $750, so that's your principal, and it's invested at 7%, which 7% as a decimal is 0.07. And we want to find the balance after 4 years, so that's my time, if the interest is compounded quarterly. So again, quarterly is 4 times a year. So what would our answer be for this one? I'm going to let you set it up. The amount is going to be your principal times 1 plus R over N times NT, and plug those numbers in and find your amount. All right, so the amount that we have is 750 times 1 plus 0.07 over N, which is 4 times T, which is 4 again. So that's going to be 16. So what will I do first? So let's say we've multiplied 4 times 4 and we get 16. What's the first thing I'm going to solve here? All right, so you're going to do 0.07 divided by 4, and you get 0.175. So you have 750 times 1.0175 to the 16th power. So you're going to raise that to the 16th power, and then you're going to oops, I forgot to add 1 to it. And raise that to the 16th power. And then I'm going to multiply it by 750. And I get 989.95. Rounding that since it's money. So be careful. If you're not getting these numbers, then you're rounding incorrectly, or you're rounding too early, and you don't want to round until you get to your final step. Okay, now, if it's compounded continuously, then we have to use a different formula. We have to use A PERT, right? And so the amount is the same thing. My principal, 750, times E to the rate times my time, which is 4. And so here you notice we're not using like the how many times per year is it compounded. And so this is what we would use. 750, oops. And then on your calculator, you can actually put this on there. So in here, you can do this. You can do 750 and then E to the, what was it? 0.07 times 4 years, yeah. And then hit enter, and you get your amount right there. Sorry for the glare. So $992.35. And that is $992.35 is more money than here. So which one's better? It would be better, I don't know why I just rewrote that. It would be better for it to be compounded continuously versus compounded quarterly, because you're making a couple dollars more for doing nothing. Okay. I think we've done enough practice for those, or I've done enough with you. What you need to do, what you need to complete is this part right here. We will check these answers at the start of our next class. So show me that you can do these. Write them out, do them now, and I will see you in class next time. Thanks, guys.